DevOps and CI-CD Part 3. This episode has 15 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Observability. Datadog. Have you used Datadog, and how would you use it for metrics, logs, traces, dashboards, and alerts? Here's a strong way to approach it. Datadog unifies metrics, logs, and traces in one platform with agent-based or API-based ingestion, which is valuable for correlating a spike in latency, metrics, with the specific traces and log lines that explain it, without switching tools. Build dashboard scoped per audience, service-level golden signals for app teams, fleet-wide health for platform teams, and configure monitors or alerts based on anomaly detection or static thresholds tied to slows. Routing to the correct on-call team via integrations with PagerDuty or similar. Nice. Let's continue. Question 2. GCP services. Cloud functions latency. A newly created cloud function had high latency for a few minutes and then automatically recovered. What could be the reason? Here's a strong way to approach it. This is a classic cold start pattern. A newly deployed or recently scaled to zero function needs to provision a new execution environment, download code, initialize the runtime, run any global initialization code on the first few invocations, which adds significant latency until enough warm instances exist to handle the traffic without cold starts. Setting a minimum number of instances, if using Cloud Functions 2nd Gen, which runs on Cloud Run, keeps instances warm and avoids this pattern for latency-sensitive functions. Great. Moving on. Question 3. GCP services. GCP cost optimization. How would you reduce the cost of a GCP environment? Here's a strong way to approach it. Start with the biggest levers. Right-sizing over-provisioned compute engine or GKE resources based on actual utilization data. Purchasing committed use discounts for stable baseline workloads. And cleaning up unused resources. Idle disks. Unattached IPs. Forgotten test projects. Reduce storage costs with life cycle policies, moving old data to cheaper tiers. Minimize cross-region or cross-zone egress traffic where architecturally avoidable. And use spot or preemptible instances for fault-tolerant batch workloads. All backed by billing export analysis to find where the actual spend concentrates rather than guessing. Alright, next question. Question 4. Containers. Docker experience. Have you worked on Docker? Explain the workflows and production concerns you handled. Here's a strong way to approach it. Production Docker workflows typically involve writing multi-stage Docker files for small, secure images, integrating vulnerability scanning and image signing into the CI pipeline, and pushing versioned images to a registry consumed by Kubernetes deployments. Production concerns include ensuring images run as non-root, resource limits are set correctly at the orchestration layer, base images are kept patched and current, and build reproducibility is maintained through pinned dependencies and digests rather than floating tags. Let's keep going. Question 5. Containers. Docker files. Have you written Docker files? What best practices do you follow? Here's a strong way to approach it. Best practices include using multi-stage builds to keep the final image small, ordering instructions so rarely changing layers, dependency installs, come before frequently changing ones, application code, to maximize build cache efficiency, running as a non-root user, and pinning base image versions to a digest for reproducibility. Also avoid installing unnecessary packages. Clean up package manager caches within the same layer they were created to avoid bloating image size, and never bake secrets into the image or its build history. On to the next one. Question 6. Containers. Docker build context. What is Docker build context, and why does it matter for build speed, security, and image contents? Here's a strong way to approach it. The build context is the set of files sent to the Docker daemon when you run Docker build, typically the entire directory containing the Docker file unless scoped with a .docerignore file. Everything in that context is available to copy or add instructions but also gets uploaded to the daemon even if unused, slowing builds. It matters for security because an overly broad context can accidentally include secrets, credentials, or .git history that end up copied into an image layer. Using a tight .docerignore is the standard mitigation. Good. Here's another one. Question 7. Containers. Docker fundamentals. What is Docker, and what problem does it solve? Here's a strong way to approach it. Docker packages an application with all its dependencies into a lightweight, portable container image, solving the classic "it works on my machine" problem by ensuring the same environment runs identically from a developer's laptop through CI to production, without needing a full VM per application. Nice. Let's continue. Question 8. Containers. Docker file fundamentals. What is a Docker file, and how is it used to build an image? Here's a strong way to approach it. A Docker file is a text file of instructions, from copy, run, cmd, etc., describing how to assemble a container image layer by layer. Docker build reads it top to bottom, executing each instruction to produce a final image that can be tagged, pushed to a registry, and run consistently anywhere Docker is installed. Great. Moving on. Question 9. Containers. Docker CMD versus entry point. What is the difference between CMD and entry point? Here's a strong way to approach it. Entry point defines the fixed executable that always runs when the container starts, while CMD provides default arguments to that entry point, or the default command if no entry point is set, that can be overridden at Docker runtime. Combining both lets you build an image with a fixed main command but configurable default arguments. Alright, next question. Question 10. Containers. Docker image optimization. How do you optimize Docker image size? Here's a strong way to approach it. Use a minimal base image, Alpine or distroless, multi-stage build so build tools never reach the final image. Combine run instructions and clean up package manager caches within the same layer, and copy only the files actually needed rather than the whole build context. Let's keep going. Question 11. Containers. Docker multi-stage builds. What are multi-stage builds, and when would you use them? Here's a strong way to approach it. Multi-stage builds use multiple from statements in one Docker file, where an early stage compiles or builds the application with full tool chains, and a later, minimal stage copies only the compiled artifact. Use them anytime your build process needs tools, compilers, dependency managers, that shouldn't bloat or expose attack surface in the final runtime image. On to the next one. Question 12. Containers. Docker image security. How do you secure Docker images before deploying them? Here's a strong way to approach it. Scan images for known vulnerabilities in CI before push. Run as a non-root user. Use a minimal base image to reduce attack surface. Never bake secrets into layers. Sign images and enforce verification. Binary authorization. At deploy time. And keep base images patched and rebuilt regularly rather than treating an image as build once run forever. Good. Here's another one. Question 13. CI/CD or GitOps. CI/CD pipeline. Explain your CI/CD pipeline from code commit to production. Here's a strong way to approach it. A typical pipeline triggers on commit, runs linting or unit tests, builds an immutable artifact tagged with the commit SHA, scans it for vulnerabilities, and deploys it to a dev or staging environment automatically for further testing. Promotion to production happens by deploying that same artifact behind an approval gate, using progressive delivery, canary or rolling update, with automated rollback if monitoring detects a regression, closing the loop from commit to safely verified production deployment. Nice. Let's continue. Question 14. CI/CD or GitOps. CI/CD tools. Which CI/CD tools have you used, and where did each fit? Here's a strong way to approach it. Jenkins fits complex, highly customized pipelines with legacy integrations where a plugin exists for nearly everything. GitHub Actions fits teams already on GitHub wanting tight repo integration and simpler YAML-based workflows. GitLab CI fits similarly for GitLab-hosted repos. Cloud Build fits GCP native pipelines with tight IAM and artifact registry integration. The right tool often follows where the code already lives and what the team's existing operational familiarity is, more than any single tool being objectively superior. Great. Moving on. Question 15. CI/CD or GitOps. Application deployment. How do you deploy applications to Kubernetes, GKE, Cloud Run, or VMs? Here's a strong way to approach it. For Kubernetes or GKE, deploy via a GitOps tool, Argo CD, or kubectl apply or Helm applying versioned manifests. For Cloud Run, deploy a new revision via Cloud Run Deploy or Cloud Deploy with traffic splitting for gradual rollout. For VMs, use a managed instance group with a new instance template, rolling update, rather than mutating running VMs in place. In all cases, the goal is an immutable, versioned artifact promoted through environments with a clear rollback path, not manual per server changes. Alright, next question. That wraps up this episode. Nice work practicing, and see you in the next one.